Alright students, let's go over our quiz for Topic 7 End of Topic Quiz. Alright, let's start with question 1. There are quite a few choices to select from for these terms. We have compound event, sample space, and theoretical probability on the first page. You'll have a longer list on your computer. Let's start with compound event, and I'm going to name and read all these to you. Is it the set of all possible outcomes, a favorable outcome, the ideal situation or what should happen, an estimate of what will actually happen based on a series of repeated trials, an investigation that has varying results, or consists of 2 or more events? Okay, so I am going to tell you that it is either set of all possible outcomes, the ideal situation or what should happen, or consists of 2 or more events. It is one of these 3. And so I've checked these off because these 3 here go with these 3. You just have to determine which order. Alright? Which means we have 2 for the other, or 3 for the other page. We have favorable outcome, an estimate of what will actually happen based on a series of repeated trials, and an investigation that has varying results. So those 3 go on the second page. Which one of those would be experimental probability and which experiment? Knowing that you will have 1 left over when you are done. Alright? Let's go on to the yearbook club is handing out t-shirts to its members. There are 5 blue, 7 green, 9 red, and 4 yellow t-shirts in all. If Jacob is handed a t-shirt, what's the probability that the color is red? Okay, so you're going to put the number of red on top over the total on bottom. So red goes up here, total on bottom, and you'll have to find the total by adding these numbers up that I underlined, and simplify if it needs to. Number 3, I'm going to take it so that it looks like what's on your computer and connect these right here. You are to complete these boxes. So see, we have a table going this way with heads and tails, and we have sample for dice 1 through 6 going this way. When you see a little box here and here, then you would put the letters or numbers that go together. In this particular case, it tells you to fill in the blanks to complete the table, and it shows that it's listing the heads or tails first and the number second. Okay? So that means you would have put H here and 1 here. And just finish your boxes accordingly. Don't miss any of them. Alright? Now question 4, right here. Using the table you completed in question 3, what's the probability you will roll a number that is even and land on heads? Select the percentage you calculate. So first, when you're done, there's going to be 6 this way times 2 that way. That's 12 possible outcomes. Okay? Out of 12 outcomes, how many do you find that has an even number, which means it has a 2, a 4, or a 6, and lands on heads? So count all the ones you see heads with 2, 4, or 6. Put that over 12, and then you do top number divide bottom number times 100 to get your percent. Next question. Number 5. Select all that apply. We can use 3 methods to organize the outcomes of compound events. What are they? Alright. Is it a list, a sample space, a tree diagram, matrix, event horizon, or table? Now, when you listen this, it's how you organize the outcomes of compound events. Alright? So select the 3 that apply. Number 6. A spinner has 6 equal size sections numbered 1, 1, 2, 2, 3, and 4. What is the sample space for the spinner? Each one of these is a sample. Keep that in mind when you select which one of these matches it. Okay. Now we're going to go to number 7. On number 7, a game has 15 balls for each of the letters B-I-N-G-O, bingo. The table shows the results of drawing balls 1,250 times. So this right here adds up to a total of 1,250. All right? And it wants to know the simplified fraction of what's the experimental probability of drawing in letter N. So you need to find N, make a fraction, and simplify. And then the next question after N is O. What's experimental probability of drawing the letter O? So you find O, put that over your 1,250 and simplify. Question number 8. On question number 8, look here, you use the spinner below to answer the following questions. All answers should be simplified fractions. First, count how many spaces there are. Then determine probability of spinning green. Look, I've labeled these for you since you can't see the colors there. Probability of spinning blue or purple, so you get to combine those. Or the probability of not blue or purple. So make a fraction over the total and simplify if it will simplify. Question 9. Right here, a complete probability model is described by which of the following statements? Is it a list of all possible outcomes in the sample space and their probabilities? Is it the actual outcomes of a trial, the number of trials conducted, or the difference between the theoretical and experimental probability of all outcomes? And last question. A probability model includes the probability of 1 is 3/10, the probability 2 is 1/5. Which of the following probabilities could complete the model? Remember, all probabilities in a model should add up to 1. All right, so that means that 1 minus this total, you can even type it in the calculator with your parentheses, 3/10 plus 1/5 would give you your answer. But you got to add these before you subtract it from 1, so you got to put your parentheses in there. All right, question 11. On question 11, if you flip a fair coin 10 times, how many times should you expect to get heads? Don't forget how many sides there are to a coin and what would be the fair amount. It doesn't want a fraction here, it wants a number, like how many times you get it, okay? And then if you can't answer this one, too bad. It says, is math the best? There's one answer only here.